Okay, this lesson is on transformations. It is a review from Algebra 2, so hopefully everything is familiar. Let's start off with the vertical shifts. If you take a normal parent function of y equals x squared and you add 3 to that, you're taking your normal function. Here's my normal x and y values, and I'm going to add 3 to those y values. And you can see 4 plus 3 is 7, and 1 plus 3 is 4, and so on. So my graph looks like this, where all my y values are being shifted up by 3. So that is a translation of up 3. So the function notation for this is you're taking your original function. So if I'm going to do this, I'm going to take f of x, and I'm going to add 3 to it. So that's my function notation. All right, so the same idea goes for this. If I have x squared minus 4, I'm going to take my original function values of my parabola, my parent function, and I'm going to subtract 4 from those values. And you can see what my new y values are. And on the graph, you can see that it has taken all my y values. Now I'm not moving anything with the x and just moving it down 4. So this is the graph of the parent function that has been shifted down 4 or translated down 4. Okay, and the function notation of that is just f of x, which is my normal parent function. And I'm going to take that and subtract 4. Okay, so that's my vertical shift. My horizontal shift, same idea, except you do have to remember one thing with horizontal shift. You can see your values of your original parabola, and we're going to subtract 2 from those x values. So negative 2 minus 2 is negative 4. So when I square that, I get 16. So if I go and plot those values on my graph, you can see that it actually moved to the right 2. So when you have this, this is moved right 2. So if you remember when you had your equation, this is going to be a minus 2, and so it's going to be the opposite for anything horizontal. The reason why is that the format of the equation is x minus h squared. So since that minus is in there, your h value is actually 2, and it is right 2. Okay, so here is another horizontal shift. So if I take those values and add 4 to them, you can see that it ends up moving left 4 units. So here is left 4 units that way. Okay, so this is left 4 over here. My function notation here is f of x plus 4. And this one is f of x minus 2. Okay, so if I wanted to graph this, you are going to do both the horizontal and the vertical shift. So this is going to be minus 2 inside. It is horizontal. So you're going to get right 2. And minus 5 is vertical. You're going to go down 5. So if I go right 2 and down 5, I'm right here. And then my key points are my original parabola. Go 1, 1, and then 2, 4. And then I just moved it over right 2 and down 5. Okay, so here's my new parabola. There you go. All right, so that was horizontal and vertical. Hopefully that sounds familiar. Now we're going to go on to reflections. And again, this should be pretty straightforward. When you're taking all your values and you put a negative up front, it takes your y values and flips it over the x-axis. Okay, so this is called, in function notation, negative f of x. Okay, all your y values get flipped over. So here's 1, 1, it goes 1, negative 1, and so on. Reflection about the y-axis, I didn't want to use a parabola on that because it ends up looking exactly the same when you take the parent function and reflect it over the y-axis. You can kind of see that when I flip this over, I'm going to get exactly the same thing. So let's use square root function. Here the negative is inside, so I have f of negative x in function notation. And you can see all my coordinates are changing with my x coordinates, switching to the opposite sign. So here the y coordinates are opposite, and here are your x coordinates. are opposite. And the y coordinates stay the same. Your key points are 1, 1 and 4, 2 for a square root function. Okay, now let's do the stretches. Okay, so here we have a little bit more to remember. If I use a graph, and I'm going to use an absolute value this time to obtain the graph of this function, 2 times absolute value of x. So I'm taking the original function and multiplying by 2. So 2 times f of x is the function notation. This one's going to be 1/2 times f of x. Okay, so again, I'm taking my y values and multiplying it by 2. So if I look at my table, you can see that when you take your y values and multiply by 2, you get these new y values when your x hasn't changed. So here is my y values being multiplied by 2. You can see this is called a vertical stretch. Okay, so this one is a stretch. And this one, all my y values are being cut in half. So if I'm going 2, 2, I'm going to go 2, 1. You can see it kind of compresses or shrinks vertically. Okay, and here's your criteria here. If the a value, we call this the a value, is between 0 and 1, it is compressed. You can see the 1/2 is being compressed. And if a is greater than 1, it kind of increases faster. So it's going to be stretched up. Okay, now the one that gives people the most trouble is a horizontal compression and shrink, because when you do this, the horizontal values are being the ones that change. Okay, so here's my normal square root function. Okay, so those are my points, 0, 0, 1, 1, 4, 2. Okay, so when I do this one, square root of 2x, my points are, this is my blue one, so I'm going 2, 2, and it looks like it should be over here somewhere. So what's happening here is this is actually called a compression, horizontal compression. And the factor is 1/2. You're going to by 1/2. So what does that mean? So normally I am at 4, 2, but to get to the horizontal point of get to my y value of 2, I'm going to only go 2, 2. So I'm cutting the x coordinates in half. Okay, so the first one was 1, 1. To get to 1 on this one, it's 1/2 1. Okay, so this is 1, and then this is 0.5 or 1/2. Okay, so that's a compression by 1/2. This one is going to be my green graph, and that is a horizontal stretch by 2. Now, if you remember from last year, it was 1 over whatever this value is for horizontal. I just like to think everything horizontal is backwards. So if you're multiplying by 2, you're actually getting a factor of being divided by 2. If you have a 1/2 or a fraction here that you're dividing by, you're actually stretching it by 2. So you're going to be multiplying your x coordinates by 2 here. So instead of going 2, 1, I'm going to go 4, 1. So there you can see your 4, 1. Okay, so this will go to 4, 1. Okay, all right. Next slide. All right, stretches and compression. If you can kind of see this with a sine function here. So here's my original function. It is a sine graph. And my vertical stretch, you can see this is a vertical because it's outside and it's my a value. So that's going to stretch it vertically. So only my y values are going to change. So notice my x values are going to stay the same, but my y values become, instead of 1, it's going to go up to 2. Okay, your original was at 1, it goes up to 2. Again, same thing here, it goes to 2, and it goes down to -2. It's being stretched vertically by a factor of 2. Now here's an example where it's a horizontal, and it is a 3 in here, so it's going to be the opposite of what you normally think of it would be. It's not a stretch, it's a compression. By not 3, you're going to do 1 over 3. Okay, so that means all your x values are being divided by 3. Okay, so when you look at this first point, it's 1/2. When you divide that by 3, you get 1/6. Notice my y value here is the same. So here I'm looking at this x value, and I'm cutting that by 1/3, and you get 1/6. Same thing here, 5 pi over 2 becomes 5 pi over 6. Okay? All right, so here's a bunch of graphs. Remember the A value, and then you got the B value, and you have a C value and a D value. All right, what did the A value represent? The one up front, all the way up front, is going to be your vertical stretch or shrink. And by whatever the factor it says is, by A, whatever that value is. Okay? It can also be a reflection over the x-axis if it's negative. Okay, the B value is the horizontal stretch or shrink, or horizontal stretch or compression. By a factor of 1 over whatever that is. Okay, and that can be reflection as well. It's reflected over the y-axis when the negative is inside the parentheses. All right, your C and D, those are the easier ones. That is a horizontal translation. And this is the opposite direction of what it is because of this minus. And then this is a vertical translation. And it is the same direction of whatever it says it is. So whatever is plus or minus at the end, that is your up and down shift value. All right, so let's do some of these together. Let's see if we can get the equation. Now, my parent function goes 0, 0, 1, 1, and 2, 4. Okay, so when you do this, look at what's going on here. Let's do a couple of them that have just been moved around. So let's skip A for a minute. Okay, so look at B. Those values are 0, 0, that's the first value, and then I go 1, 1 on negative 1, 1 on the other side. So all I've done is take my original graph and moved it up 4. So this is just going to be x squared plus 4. Okay, you want to write f of x up front. That looks better. All right, the next one over here, again, I notice my first point is 1 away, 1, 1 on either side away. So that is just moved to the right 3. My vertex is not at 0, 0. So if I want to write right 3, I'm going to do f of x equals, and over here, right 3 is minus 3 squared. Okay, and let's also do e because that also looks like it's just been moved around and reflected. And so that moved to the left 5 and reflected. So that one was E. I guess I'm not putting these in the right spot. So that one left 5 and reflected over the x-axis. So that is f of x equals, and I need a negative up front, and then that's going to be x plus 5 squared. And put these in the right spot. Okay, so B was the one that was up 4. So that's going to be x squared plus 4. Okay, and then C was the one that was right 3. So that one is f of x equals x minus 3 in parentheses squared. D and A, and I don't see an F, so yeah, let's get rid of that. D and A are both stretches, involve stretches. So let's look at D. Notice that it went 1 and looks like -5. So it's been vertically stretched by a factor of 5, but it's also been reflected. So that's going to be f of x equals reflection, negative up front, and then multiplied by 5. So it's 5 and then x squared. Okay. And then the last one is A. Notice I don't go 1, 1. My first point that I can find on A is right here. It's 4, 1. So that's actually been stretched horizontally. Okay. It actually has gone by a factor of 4. So it is actually going to be 1/4 because it's going to be f of x equals parentheses 1/4 x squared. Okay. All right. So now we have some general function questions. So what do all these things mean? So you should be able to get the negative in the front, the 0.5 in the front, the -2 inside the parentheses, and the +9 outside the parentheses. Okay, you can go ahead and answer the question about that. If I'm going to graph this, let me look at my actual transformations. This negative means it's a reflection over the x-axis because it is up front. And then I have a +1 at the end. So if I translate and it's gone up 1. And then I also have a 2 here, which is a horizontal. Okay, is that going to be a stretch or a shrink? It's going to be a compression or a shrink. I like to use the word shrink, but you'll see compression in a lot of books. So horizontal shrink by 1/2. Okay, so I'm going to reflect this over the x-axis. I'm going to shrink it by 1/2, and I'm going to go up 1. So I'm going to go ahead and go up 1 because that's going to be my endpoint. This is a square root function, so you have an endpoint. All right, so normally I would go 1, 1 and 4, 2, but I'm going to take those points and I'm going to shrink it by 1/2 horizontally. Okay, so instead of going 1, 1, I'm going to go 1/2, 1. Well, there's one more thing I have to remember, that I'm reflecting it over that axis. So it's going to go 1/2, 1 from that point here. And then I'm going to go 4, 2. So I'm going to go 4, 2, 2, because I'm shrinking it horizontally by 1/2. And then the next point is 9, 3. So I'm going to go 1/2 of that distance, 4.5. Then go 1, 2, 3. And here's my graph. Now you can make a table of values. That might be easier for some of you, and do these things to it. So if it's up 1, you're going to change your y value by 1. You're going to shrink your horizontal by 1/2, and then you're going to reflect it over the x-axis, means the y coordinate changes. All right, so let's look at some random general functions which have no function names to it. They're not our parent functions. So if I look at this graph, and this means it's going to go right 3 and up 2. And again, if you want to make a table of values, you can, and just change your your x values to be added 3 and your y values to be added 2. So I'm going to take all these points and just go right 3 and up 2. 1, 2, 3, and up 2, 2. 1, 2, 3, and up 2. And this one is 1, 2, 3, and up 2. And then it's going to go from there. So I'm going to have this graph here. And we continue up this way, and then it goes like this. Okay, let's try another one. Let's just try, let's do f of negative x. Okay, so that's going to flip my coordinates over the y-axis. So this will come over, this is going to stay the same, it's on the y-axis. All right, so this is going to come here, 1, 2, 3. It's going to go 1, 2, 3. This is going to go over here. It's going to go 1, 2. And then this point right here is going to come on this side. And this point over here is 3.5-ish away. So I'm going to go over here 1, 2, 3.5-ish this way. So here is my graph when it is reflected over the y-axis. This should be over here. Okay, so that's a reflection over the y-axis. Now, if I want to do something else to this, I could. If I want to take that and go -2, I'm going to take all these points and move it down 2. Okay, and then what about this one? This is -2, which means it is going to be reflected and it's going to be stretched by a factor of 2 and up 1. So I'm going to go ahead and draw this reflection first and stretch of 2 go along with that. So here I'm going to reflect this over the x-axis and I'm going to move it down 2. So that point goes here. And then this point here goes up here and then gets multiplied by 2, goes there. This one goes here, gets multiplied by 2, it's here. This is 2 away there, so it's going to go 4 here. Okay, and then I have this point here, which is going to go there, and it's going to connect here. Okay, so, and then this is going to be straight across here. It's going to go there and multiply by 2, and same thing. So this is my graph so far. Okay, now I'm going to take all these points and move it up 1. So my new graph looks like this. All these points are moved up 1. Okay, so that's my new graph. All right, so that is it for transformations.